Pune College of Engineering and Technology, Department of EEE, Subject Code 20E601, Power System Operation and Control, Unit 4, Unit Commitment and Economic Dispatch. Syllabus. So these are all the topics we are going to cover. The Unit 4, Statement of Unit Commitment, and then Statement of Economic Dispatch Problem. So two different topics we are going to discuss in this unit. First one, thermal constraints. A thermal unit can withstand only graded temperature charges and is required to take some power to bring the unit online. The thermal plant 1 hour is the smallest time period that should consider for unit commitment solution. Startup and shutdown time for many units is the order. So minimum uptime. Once the unit is running, it should not be turned off immediately. So minimum downtime. Once the unit is decommitted, there is a minimum time before it can be recommitted. Crew constraints. If a plant consists of 2 or more units, they cannot both be turned on at the same time, since there are not enough crew members to attend both units when starting up. Startup cost. It is dependent upon the downtime of the unit, the time interval between shutdown and a restart. Startup cost when cooling. During downtime period, the unit's boiler to cool down and then heat back up to operating temperature in time for a scheduled turn on. Startup cost when banking, that means a shutdown cost. During shutdown period, the boiler may be allowed to cool down and thus no shutdown cost will be incurred. Startup cost when banking is equal to Ct into T into F plus EF. Here, this small heating curve, consider for x-axis time and y-axis your startup cost. The cooling of the system, it will be like this, the curve. Hydro constraint. So these constrain hydrothermal scheduling to allocate the maximum hydro units during raining season and to allocate thermal units during remaining periods. Fuel constraints. If thermal and hydro source are available, a combined operation is economic and advantageous to minimize the fuel cost of thermal unit over a commitment period. Daily load curve. So the x-axis is in time in hours and the y-axis is load in megawatts. Share of pumped storage plant. The contribution of hydro power plant with the storage and then generation of thermal plant, power from runoff river plant, and then thermal energy using for pumping systems. So unit commitment solution method. To form the loading pattern of M period using load curve, commit possible number of units to be operated to meet out the load. To determine load dispatch for all feasible combination of solution for each load level and satisfying operating limits of each unit. For first thing, brute force technique or simple priority list method. The brute force technique method, M periods and the number of combination to try 2 power n minus 1 power m formula. Constraint. So the unit commitment will be committed to supply the load. Summation I is equal to 1 to n PGI less than PD. Infeasible solution are to decommit the generating units. Summation I is equal to 1 PGI greater than less than TD, that means a feasible solution or commits 1 generating units. So PD means power demand and PG means power generation in ith unit. Next one, peak valley pattern. If the operation of the system is to be optimized, unit must be shut down as the load get down and then recommitted as it goes back. So this brute force technique, we have to commit the different units, draw the one characteristics of x-axis considering time in hours and y-axis is total load in megawatts. The unit, so here simple mistake. So unit 1 and unit 2 and unit 3 and unit 4, that is the peak value point. So priority list method using FLAPC, that means full load average production cost. First step, full load average production cost, find out the each unit. Second one, from priority order based on average production cost ascending order. Commit number of units corresponding to the priority order. Calculate from economic dispatch from the feasible combinations only. For load curve, each hour load is verifying. Determine the number of hours to check the minimum shutdown time. If suppose the signal is yes means go to last step. If not satisfied means go to the next step. Calculation the two cost method, that means minimum cost and maximum cost. Some hourly production cost for the next hours. Recalculate the same for unit down plus startup cost for either cooling or banking. If the second case is let's say less expensive, the system is repeated for this until the priority list. Next on dynamic programming method. So we having one flowchart to start the program. To read the value of unit A, B, C, minimum value and maximum value. Using economic dispatch, find out the value of generation of each unit for different load levels. Next to K is equal to 1. So fuel cost K, I is equal to minimum level, and then K is equal to K plus 1. So we have to analyze the flowchart for one by one. So next part, the necessity of economic dispatch. In many cases, economic factor and the availability of priority essential, such as coal, water, and dictate that new generating plant is located at greater distance from the load center. The installation of large blocks of power has resulted in the necessity of transmitting power out of a given area until the load in that area is equal to new block installed capacities. Generation strategies. This is a spinning reserve. This is peak load, controlled generation, total system demand. It's a time we have to consuming. This is a base load. The spinning reserve, peak load, these are all the things we have to discuss in the unit 1. Next, daily load curve. Base load unit, intermediate unit, peak unit and reserve units. Base load. So nuclear units full under this category. So nuclear power plant only consider for this base load unit. And the intermediate units, hydro power plant we are going to consider. This studied in this case of where power output has to be regulated. Next, peaking units. The sudden increases in the load, best choice is the gas turbine power plants or pumped storage power plants. Reserve units. The generator which is maintained at partial output and generated which are ready for operation comes under these categories. What are the problems involved in these units? Economic dispatch. The purpose of economic dispatch or optimal dispatch is to reduce fuel cost for the power system. By economic load scheduling, we mean to find generation of the different generation of plant. Methods: base load method and a base Best point loading. So base load method where the most efficient unit is loaded to its maximum capability. Best point where units are successively loaded to their lowest heat rate point, beginning with the most efficient unit and working down to the least efficient unit. Optimal operation of generation on bus bar. Generator operating cost. We have to find out the total operating cost including fuel cost and transmission cost, labor cost, maintenance cost, simplicity of all fuel cost. Cost generation depends on operating constraint or system. Equality constraint, inequality constraint, voltage constraint, running space capacity constraint, transformer tap settings, transmission line constraints, and network securing. So running and transformer tap changing costs. Transformer tap changing already discussed in this last unit, third unit. On-load tap changing transformer and off-load tap changing transformer. So input and output characteristics of generating units, output power, operating fuel costs, minimum loading limit and maximum loading limits. This is called a heat rate curve. Output power in megawatts and the heat rate in considering y-axis. The incremental cost rate is equal to change in fuel cost divided by change in power demands. So 1 megapascal is equal to 1.164 megawatt hour is the electrical equivalent of heat. The incremental efficiency is defined as the reciprocal of incremental fuel rate or incremental production costs and is given by incremental, that means change in fuel divided by change in cost. Incremental cost for received power or system incremental cost. So this is the thermal power plant heat rate, and then input and output curve for this hydro power plant. Next on two area systems, area 1 and area 2 for this incremental cost curves. Economic dispatch formulation. The goal of economic dispatch is to determine the generation dispatch that minimizes the instantaneous operating cost. Subject to the constraint, the total generation is equal to total load plus losses. Economic dispatch Lagrangian's interpolation formulation. For the economic dispatch, we have a minimization constraint with a single equality constraints. So these are the necessary conditions. Inequality constraints, and then coordination equation without losses is considering for two generating different units. So Pg1 plus Pg2 and then demand PD1 plus PD2. We have to minimize this equation using operating cost and the number of generators. So using this Lagrange's multiplier function lambda value, find out this function. So this is the demand and the generating capacities mainly we are considered. For minimization of the objective function, differentiate the above equation with respect to Pgi and equal to 0. So graphical representation of economic dispatch. Next one, coordination equation with losses or exact equation. The same as we have to find out the demand and the load capacity. That means the transmission losses including the flow chart. This given economic dispatch with losses. So for this example, so another type of examples. Next one, lambda iteration method. The lambda iteration method, this method is referred to unique mapping from a value of lambda to each generator megawatts ranges. For any choice of lambda common marginal cost, the generator collectively produce a total megawatts output. The method then starts with the value of lambda below and above the optimal value. So thank you.